Okay, the last type of two-sample testing that we're going to be talking about today are two-sample proportion tests. So the purpose of a two-proportion significance hypothesis test is to see if two proportions are different in some way. So the null hypothesis would mean that there's no difference between the two proportions, or P1 is equal to P2. And then the alternative hypothesis can be our standard three options, where P1 is not equal to P2, P1 is greater than P2, or P1 is less than P2. Here is the formula for the test statistic for the difference between two proportions. So we're going to take P hat 1, which is the sample proportion for the first sample, minus P hat 2. We normally subtract off the population difference here. But again, the null hypothesis is that P1 equals P2. So if we were to subtract those two population proportions, we would get 0. So we could see a minus 0 here in some books. Just to simplify things, we're just going to say P hat 1 minus P hat 2 divided by the square root of the combined proportions, the combined sample proportions. P sub 0 is the notation that we'll use for that, minus 1 minus P sub 0. That could also be notated as Q sub 0. So over here, we talk about how to find P sub 0. Again, it's the combined proportion. So we're going to add x1 plus x2, or the number of successes from each sample together, and then divide by the total sampled. So the first sample plus the second sample, again, combined together to give us the total sampled in both. Then we multiply that proportion by 1 over n1 plus 1 over n2. Just another note here, guys, P sub 0 and 1 minus P sub 0, those are complements of one another, or if you choose to call them P sub 0 and Q sub 0. So if P sub 0 is, let's say, 40%, this value would then be 60%, or 0.4 and 0.6. Okay, we'll get into that a little bit more when we look at the examples. We do use the z-chart to find any critical values for our step number 2. All right, let's take a look at that first example. It says, suppose the Acme Drug Company develops a new drug designed to prevent colds. The company states that the drug is equally effective for men and women. To test this claim, they choose a simple random sample of 100 women and 200 men from a population of 100,000 volunteers. At the end of the study, 38% of the women caught a cold and 51% of the men caught a cold. Based on these findings, is the drug more effective for women? Use an alpha level of 0.05. Okay, so to start this, if there is truly no difference in the proportion of men and women who get sick, then our null hypothesis would say that P1 is equal to P2. Or in other words, the proportion of women that get sick is no different than the proportion of men who get sick. The alternative hypothesis, we look for any keywords. We see that we want to test, is the drug more effective for women? So if the drug is being effective in preventing a cold, then we would want the proportion of women, or P1, to be less than the proportion of men, or less than P2. Again, more effective is meaning a less percentage of women getting sick. All right, step number 2 to test that alternative hypothesis where P1 is less than P2, we would shade the left tail region. We're using an alpha value of 0.05. So if I look up 0.05 in the middle of the Z curve, let's go to that Z chart for a second. I'm scanning this middle for the closest number to 0.05. So if I look, I see 0.0505 here and 0.0495 here. If we follow both of those out, we see negative 1.64 and negative 1.65. We average those two together since they're evenly split, so my critical value is negative 1.645. All right, step number 3. In order to find the z-test statistic, I would take the first sample proportion, which for women was 38%, minus the proportion of men, 51%. I would divide that by the square root of the combined proportions. So if 38% of 100 women got sick, X1 would be 38. If 51% of the 200 men got sick, that means that out of those 200 men, 102 of them got sick. So in order to find P sub 0, I would add those two successes together. So 38 plus 102, and then divide by the combined sample sizes. Again, we said 100 women and 200 men. So if I add those together, we're talking about 300 people. So basically our combined proportion here is the total number of people who got sick out of the 300 people in the sample. All right, so if I add those together, that gives me 140 over 300. All right, so if I turn that into a percentage, if I divide those two values, I get about 47%. I'm going to round that to 47 just for ease of use. So our P sub 0 is 0.47. The complement of that is 0.53. So that's the 1 minus P sub 0, or if you wanted to indicate that as Q sub 0, we see that a lot. I would multiply that by 1 over N1, which that was the number of women in the sample, plus 1 over N2, which was the 200 men. That is all underneath the square root sign. Guys, I'm showing that formula, but we are going to be using the calculator to calculate that test statistic for us. So if we go to stat over to tests, we're looking for the 2 proportion z-test. Going to ask me for X1, which we calculated here as 38. And N1 was 100 women. X2 we calculated here to be 102. And N2 was 200 men. Our alternative hypothesis is less than, so we're going to highlight that and now calculate. The calculator will do that math for us, and we get a t-test statistic of negative 2.13 with a p-value of 0.0167. I'm going to go ahead and erase this so we have enough room to write down those values. So for step number 3, the test statistic, we said earlier we get z equals negative 2.13. Step number 4, we have a p-value of 0.0167. P is less than alpha. So when P is low, our decision is to reject the HO. When P is low, reject the HO. So we're rejecting the null hypothesis. So to answer their question, is the drug more effective for women at alpha equal to 0.05? The drug does seem to be more effective for women than men. In other words, the proportion of women who get sick is less than the proportion of men who get sick while using this new drug. All right, guys, here's the U-Try. So go through those 6 steps for this 2-proportion z-test example, and then unpause the video to see the results. Okay, here are the results of that hypothesis test. So step number 1, our null hypothesis, P1 equals P2. Our key word was just difference. Is there a difference between these two? So P1 does not equal P2 for the alternative. Our critical value was positive or negative 1.96. That has an alpha value of 0.05, but we split it between the two tails. So I looked up 0.025 on that Z chart in order to find that critical value. Step number 3, let me show you what I entered into the calculator here. We go to tests and then down to the 2-prop z-test. Plugged in the values pretty much straight from the prompt. It gave me the X values, the number of successes. In this case, a defect is a success, out of the sample size for each line A and line B. So 18 out of 200 and 25 out of 600, we are testing a not equal to case. So if we calculate that, that gives me a z-test statistic of 2.62, a p-value of 0.0087. Our p-value is less than our alpha level, so when p is low, we reject the HO. So if we're rejecting the null hypothesis, that means we're getting rid of the idea that the 2 proportions are equal. So to answer their question, is the differences between the 2 assembly procedures significant? At alpha equal to 0.05, there does seem to be a significant difference between the 2 assembly procedures. All right, guys, this concludes notes for today.